All right, here we go. No, she's coming. All right, overview of improper integrals. You guys already have all the tools because we've been doing integration for a long time now. So there's only one new thing that you have to know, and we're going to cover that right now. So before we get into it, let's talk about the concepts behind improper integrals. Sometimes area under curves converge, and sometimes area under the curves do not converge. So here's an example. So I have some function that looks like I have a horizontal asymptote at the x equals 0. I mean x equals 0, y equals 0 line, because I can see the double arrows over here. So sometimes this converges. So look, they told me, they said let f of x be the function graph below with the given integrals rounded to the nearest thousandths. And they tell me f of x from 0 to 5 is 3. They go from 0 to 10 is 3.09, from 0 to 15 is 3.098, from 0 to 50 is 3.099. So then they say, find the following limit to the nearest hundredths if it does not exist, write D and E. Look what they say. From 0 to b, where b is approaching infinity. Does this look, as the top limit gets larger and larger, 5, 10, 15, 50, does it look like it's converging or diverging? Converging. What number does it look like it's... Say it again. Oh, diverging means I'm not approaching any number. I just keep growing and growing and growing. Yeah. And converging means that you're approaching a specific value. Sorry. Yes. Well, if it's converging, it has a limit or it has a value, and if it's diverging, that means I'm not approaching anything. It just keeps unbounded. Okay, sorry, I forgot that we're rookies on this, and I gotta. Okay, yeah, ask me questions on whatever. Yeah. All right, so here we go. B approaches infinity. Does it look like it's approaching a specific value? It does. What number? It says nearest hundreds, but yeah, I don't see nearest hundreds here because I see like it's approaching what? 3.1. So there it is. So then it says complete the sentence. The integral from 0 to infinity of f of x dx converges to 3.1. And that's it. That's all you're doing. Cool or not cool? Okay, so look at this one. So I'm assuming that this should have probably gone forever up, but that's fine. Or I guess my horizontal asymptote looks like it might be that negative 3.2. But it's fine. Don't worry. Look, it goes from negative 10 to 0. It's this value. From 0 to 10, it's that value. So it looks like it's symmetric. Yeah, it is symmetric. Find the following integrals to the nearest thousandths. From negative 10 to 10. Well, that has a value because look, from negative 10 to 0, it's that. And from 0 to 10, it's that. So from negative 10 to 10 of f of x dx, you just add them. Add this plus this. So take your calculator. You're going to need a calculator. And then just take that number and multiply it by 2. Oh, you found it? Okay. 25.587 times 2. What is that? Or you can just do negative 25.587 plus negative 25.587. 174. Nearest thousandths. Yeah, that's fine. All right. What is it from negative 20 to 20? Go ahead and add up the negative 55.437 or multiply those by 2.
Negative 110.674.
There it is. And where did it go? 874. I can't write that little edge here. 874. All right. Negative 50 to 50. 696. Hey, Ramirez, all they did was they just combined them, right? Negative 50 is the lower limit, 50 is the upper limit. So, yeah. Right. So, yeah. Hopefully you guys watch them and hopefully it brings you a smile. Hopefully. We'll see. All right, here we go. So now it says this. Find the following limits to the nearest hundreds. If it does not exist, write D and E. Here's what we should be observing. Look at this one right here. From negative 8 to 0, notice, so here's my top limit, 0 all the time. So the bottom limit is just growing fast, well, growing in the negative direction. Negative 10, negative 20, negative 50. Do these numbers look like they're converging or do they look unbounded? Just keep growing. Yeah, it's diverging. So this one, I'm going to write does not exist. Because that's what it tells me to write. Oh, hey, you're back. We just did a shout out to you, but you're back, so okay.
I'm good. My mouth is numb.
Oh, you're good.
I've been surviving off of Mad Libs, but now I got Macaroni and cheese.
Yeah, she's back.
Oh, I like your shirt. I'll
Right.
be there on Friday.
All right, guys. Let's focus. Let's focus. Don't worry, we're almost done. So both of these limits do not exist. Notice this does not have the word limit on it. Well, we'll talk about what's the right way to write this down. So from negative infinity to infinity, because I don't converge to any specific value, this is going to have to what? Diverge. So this diverges.
So then we don't need to finish.
That's it. Yep. And that's it. Cool or not cool? Okay. So now let's go. Oh wow. Let's get to the real stuff. I feel all this is lame. Let's get to the real stuff. Look at question number 5. Here's how you really do it. So it says evaluate the integral from negative infinity to negative 1, 5 over 3x plus 2 to the third power dx, or state that the integral diverges or express your answer. All right. Anytime you have a limit that has infinity, do not do the antiderivative and plug infinity. You cannot do direct substitution. If you're doing a multiple choice and they're not going to ever see your work, then that's fine. But on the free response, this is very common. You have to write it as a limit. I always go down the alphabet. Delta Math has the lower limit always as A, always, and I don't like that. And they have the upper limit always as B. That's Delta Math. If you want to do it that way, that's fine. Some textbooks do it that way too. I just go down the alphabet whenever I need it. So what do? I see a symbol, the infinity, so I do it like this. I write limit, and I just start with the letter A. As A approaches negative infinity, and write integral from A to negative 1 of 5 over 3x plus 2 to the third power dx. Are we okay with that? And then here's what you say. You just take your antiderivative like you always do, but don't forget to write that limit down. So here it is, that limit as A approaches negative infinity. And then I'm going to put a bracket, and I'm going to do the antiderivative of that. So let's see. I have that 5. And then, no, you guys are in BC. We know how to do it. Over, let's see, 3x plus 2 to the power 2, because, it would have been positive, or, you know what I mean? Like, it's like u to the power negative 3, add 1, divide by that number. You know what I'm talking about? But we're not done yet. Yeah. Then it would have been times 3. Okay, you want to do use up? All right, let's go to the side. Yeah. All right, let's go here to the side, and you go integral 5 over 3x plus 2 to the third power dx. I'm going to go u equals 3x plus 2. Du equals 3 dx. So I'm going to insert a 3 in the top times 3, put a 1/3 on the outside. So 1/3 integral of 1 over, oh, that 5 is still there, right? So I'm going to put the 5 over here. I'm going to put the 5 right here, guys. That 5 is this 5. 1 over u to the third du. Bring that up. 5/3 u to the negative 3 du. So 5/3 u to the negative 2 divided by negative 2 plus c. So what is all that? Negative 5 over 6, parenthesis, 3x plus 2 squared. Close the bracket, put a lower limit a, put an upper limit negative 1. Do we feel okay? Okay, then you're going to write this. Still continue with the word limit because we haven't evaluated it. Limit as a approaches negative infinity. Bracket, and I'm going to do upper. So I'm going to factor out that negative 5, 6 on everything. Negative 5, 6, another giant parenthesis, and here we go. 1 over parenthesis 3 times negative 1, close, plus 2, close, squared. I don't see any mistakes. Minus 1 over, you okay? 3 times a plus 2, that's an a, plus 2 squared. Close giant parenthesis, close bracket. So let's see what I have. Limit. That's my upper limit. Three times negative 1 is negative 3, plus 2 is negative 1. Negative 1 squared is 1. Minus, I don't see any mistakes. I'm going to leave this like that. 1 over 3 parenthesis a, close that, plus 2, close it squared. I'm going to leave it like that. Oh, I'm sorry. There's not. Oh, the answer's coming up. So you don't need. This is all the room you need. Equals. You look at this. What is A approaching?
That's approaching.
Okay. So.
1 plus.
So think about it.
1 over
Yeah.
So 1.
Yes. Well, 1 times negative 5, 6. The denominator is growing unbounded.
Yeah.
So 1 divided by a huge number is. Sorry, I saw. Oh, Gonzalez texted. 0, and 1 minus 0 is 1, and 1 times negative 5, 6. So this converges to negative 5, 6. Express your answer in simplest form. Oh, well, there it is. Should I look at the key? Yeah, let's look at the key. There it is. Converges to negative 5, 6. They don't show any work. They just give you the answer.
So it's kind of like saying 1 minus 0.
1 minus 0.
Okay.
All right. Well, I don't want to look at the other one because then I'll get the answer in my head. All right. Ready for the other one? Number 6. I'm going to go slow. Oh, we just did number 5. No, we didn't do number 4. Yeah, it's kind of lame and it's kind of weird also. No, don't worry about it. Okay. First thing you do. So you guys tell me, what do I got to write in the front? Limit? Yeah. Yeah. Delta Math would have written the letter B. I just go down the alphabet as you need it. Integral, just make sure that the upper limit is that same letter. If you don't like the A, B, C, choose whatever letter you want, but make sure you're consistent. Yeah, you can put B. What if you were to put C? Do you like? So you like the upper limit to always be B and the lower limit to always be A? That's fine. That's fine. No, you're good. You're good.
Oh, I see that most often, and I recognize that.
All right.
I like X.
No, don't use X because X is off limits.
So that's why I'm not using
Don't use X. Don't use Y. Don't use Z, or I,
what? Well, yeah.
or J,
X is what
or K. You can use anything else though,
So, like,
because IJK is using the dot product and
A, B, or C.
A, B, or C. Yeah, A, B, or C is fine. All right, here we go. You guys ready? Equals, and I'm going to write the word limit again because I haven't evaluated it as A approaches infinity. Let's see if we can do this without U sub. This is going to be, it looks like I have a negative in the front. Negative ln, absolute value, 3x minus 6, close it. Yeah. Close the bracket and put lower limit 7 and put upper limit A. Are we okay so far? Okay. Next, I'm going to go ahead and factor that. So I'm still going to write limit because I haven't solved it. As A approaches infinity. If you wrote B, that's fine. No big deal. Bracket, negative infinity, giant parenthesis. Ln, absolute value. 3A minus 6, close the absolute value. Minus Ln, absolute value. What's 3 times 7? 21 minus 6. I factored out the negative. Okay. 3A minus 6. Before you solve, I mean, I guess you could combine them if you wanted to, but I think this is good enough right here. Yeah, this is good enough for me. I think actually it's good enough for the free response too. Oh, man. Lopez, you are leaving? Okay, yeah, because 7 is a little different. So, all right, the A guys. Well, I guess this expression here, you can already evaluate it. As A approaches infinity, what does this approach? No. Infinity. Ln keeps growing very slowly, but it keeps growing forever.
But we still have a. So is it going like negative into the sixth place?
So yeah, no, ln guys, ln looks like this.
Not that one. I meant whenever you put it all together, this is in the denominator.
It's not in the denominator. This is in the numerator. I have the factor out on the outside, the negative. This is ln absolute value. Put the negative in the front. 3a minus 6 over 15. See? Oh, it doesn't matter.
Well, because the negative was.
Then you would have a negative right here and a positive there.
No, she's saying.
That's what she's saying.
No, she's saying because you know how with Ellen, like the properties say that like if we had if we had like an coefficient of 2,
Uh-huh.
it was like 2 ln of like x or something, then
Uh-huh.
it'd be ln of x later. So then wouldn't
Yeah.
you put it as oh.
Ask.
Yeah, if we switched it. So we were like, if we had negative ln of 3b minus 6 plus ln of 15, then if we switched, it would have been ln of 15 minus ln of 3b minus 6. Yeah.
It would have been the same because I still have that. So if I distribute the negative, it would be ln of 15 minus ln of 3a minus 6, like that.
Yeah, and then 15 over 3a minus 6.
Oh, it's still going to converge. Ln of 15 over, but you can't have 0 in ln because it grows to negative infinity. This is ln of 0, but the domain of the inside expression is always, well, the inside expression, well, it's not x, but y equals ln of x. X is always greater than 0. If I approach 0 from the left-hand side of ln, or from the right-hand side, because there's no left-hand side, it just goes down to a negative infinity. So even if I were to go this route, it would still diverge. It would not be, you would not get a value. This is still diverging. Because if you approach, you can't have a 0 inside of ln. You just can't. The x value is approaching. This is the inside, the argument is approaching 0. The output of it isn't. The output is a huge negative number. And that's what I'm looking for, the output of this. Okay, let me do this real quick, because limit as x approaches 0 of ln of x. There, that solves your issue. Converge or diverge? Does not exist. I know how ln of x looks like. That graph looks like this. So if I approach 0, and I gotta put from the plus, because there's only one direction. If I approach 0 from the right-hand side of ln of x, this is negative infinity. That's what this is. If I write it like this, this is approaching, as limit is approaching negative infinity. It doesn't matter how you do it. It's still going to get negative infinity. But do you see it? So if I do it with the, look, check it out, because I want to make sure that you know. If I do it with this factored out, didn't I say this was infinity? You still get negative infinity.
Let's go.
Okay. So this one diverges. And don't worry, I'll check the answer to make sure that I'm 100% sure it diverges, but look, here's the key. And look, I haven't seen it yet. You guys ready to all see it? I'm going to make a bet that I did last time, but this time I know I'm 100% right. If I'm wrong, we have pizza next time we meet. You want me to be wrong. No, look, I haven't seen it yet. Look, I bet you that I was not worried at all. Not even a little bit. Diverges. There. Okay, deal's off for the next one because I haven't seen it yet.
Wait, so whenever they say it's diverging, does that basically just mean that it's not symmetrical?
No, doesn't mean that at all. Because you can be symmetrical and still diverge. We're going to be doing a problem pretty soon, 1 over x. You're going to see that one of them is going to converge, and then 1 over x squared, you would think that it converges even faster, but it's going to diverge. You're going to see. After you're going to do a whole bunch. If it diverges, it just means that you're not reaching anything. You're not bounded. Sometimes those areas are bounded, and sometimes it doesn't. And sometimes it's not going to make any sense.
So it's like an infinite.
Yeah. We're going to do something called the devil's horn, and you're going to see that one has infinite area, either the one or the other. Either infinite area with volume with a finite volume, or finite surface area with infinite volume, which doesn't make any sense one way or the other.
Okay.
Yeah, you'll see. All right.
So I have a question.
Okay, what's
So
up?
divergence basically means that your limit doesn't exist.
Correct. That the integral is not converging to anything.
It's not converting to.
Yeah, it's not bounded. Remember, this means area under the curves, right? We're finding area under the curves, and that area we can't calculate it. It goes forever, unbounded. Like saying how the graph 1 over. I'm just making this up because I want you guys to have an idea. So it's how the graph 1 over x looks like, right? Y equals 1 over x. That never touches the x-axis, correct? Or the y-axis. It looks like this. It also looks like this, but I don't care about. Let's just say I'm looking at this. So if I told you what is the area under the curve, I can never touch 0. So I'm going to say 0 from the right-hand side to infinity. Well, this is a double whammy. Let me just say 1. 1 to infinity of f of x, of 1 over x. Well, sometimes it converges, sometimes it diverges, sometimes. What that mean?
Did you see that?
What was that?
It was my split.
I didn't know where it came from. I was about to say, I can't believe I spit.
No, is it pink? It's my split.
Yeah.
Yeah, that'll do it. That wasn't me though. I actually went like this.
Yeah, don't do that. Don't do it again.
It's not like I purposely was like a paper towel.
Yeah, for you YouTube fans are wondering what's happening, I just had a big drop fall on my laptop, and I thought it was spit. I thought it was me initially, and I was actually scared. I was like, maybe I need to go to the doctor if I don't even know. I don't even know how much volume it was in my mouth. That, you know what I mean? No, you really did get me scared. The first thing that came to my mind is, man, I must be getting really old. For real, I must be getting, because I looked up, there's no leak, and the next step, my next logic in my brain was, it must be me. It must have come from my mouth. So I'm analyzing, and I'm like, man, my mouth must be nasty for it to.
I thought something fly, and I thought, and it went under, and I saw the one that went under. Oh my God.
There was another one that came
and
right.
then I saw you look at me
I wasn't looking at you. I was looking at this. Maybe I was cross-eyed. Okay, I'm glad we caught that on video because it's all being recorded. Okay, here we go. What was that going? Oh yeah. See how this look? Real quick, guys, real quick, and I'll stop right here. This is the 1, and look, I'm finding all this area, but notice that I'm unbounded. It's going to infinity. Sometimes this area converges, sometimes it doesn't, because we're adding all these little areas. It never touches the x-axis. So you know what I mean? So you're adding forever and ever and ever and ever and ever. When you keep adding forever and ever and ever, sometimes it converges, sometimes it doesn't. Cool, right? All right, so check it out. Let's do this one here.
I don't know the literal definition of divergence.
Unbounded.
I'm thinking 8th grade earthquakes.
Yeah.
Convergent or divergent?
Yeah. No. Yeah.
Divergent.
Diverging means you're unbounded. You're not approaching any specific value. Okay. Here we go. Why is this one an improper integral? Whenever you get this one, do not do antiderivative of that and then put a 3 and then put a -1. It looks like a regular integral, but notice you are not defined when x equals -1. Not defined. Do you guys see that? So we can only approach -1 from one direction. Look what my upper limit is. It's 3. So we can only approach -1 from what direction? The right or the left? The right. Roberto, are you following along, Roberto? Okay, focus, let's focus. All right, so here we go. I'm going to rewrite this. I'm going to write the word limit as a approaches -1, but I can only approach it from what direction? The right of integral from a to 3 of 1 over x plus 1 to the 3/4 dx. You must write it like that. If you evaluate it immediately, wrong. Because you can't evaluate it at -1. Are we clear on that? Okay. Next, antiderivative. Can we do this without u sub? Limit as a approaches -1 from the right-hand side, bracket. That -3/4, add 1.
So 4 over 7.
So x plus 1 to the 1/4, right? And then I'm dividing by 1/4, so I put a what in the front here. 4, and since that x is a 1, or you just leave it alone. Are we still okay? I don't see it. I don't see any errors. Everything looks good to me. Okay. Okay, here we go. Limit. As a approaches -1 from the right-hand side, bracket, I do the upper. 4, 3 plus 1 is 4. Oh yeah, this one, leave it alone. 4 to the 1/4 minus, and I already put a 4 there, so I'll just keep with the 4. I should have factored it out, but no big deal. 4 parenthesis a plus 1 to the 1/4 close bracket equals, and you have enough space. You don't need any more. Okay. As a approaches -1, I can just do direct substitution now. What's -1 plus 1? 0. 0 to the 1/4 is 0. So this is my answer. 4 times 4 to the 1/4. You can actually combine them together. What's that? 4 over 4, 4, 5/4. 4 to the 5/4.
Oh, sure. Oh, that's not what I thought.
Oh, you know what? We got the key. I just I don't know why we didn't remember that. Let's see how they left it. I haven't looked at it, so let's see.
Like 4 times 4.
They're lame. They're lame. I thought they would have been more clever than that.
No.
I thought, no, I mean, it's a computer, right? I thought they would have been more clever, but that's
I
fine.
don't know. I find that sometimes you know.
So here's the answer. I would have thought, because it's an AI, so I would have thought that it would have done that, but it's the same. 4 times 4 to the 1/4 is the same thing as 4 to the 5/4. Don't,
You're adding 1.
yeah,
And so
Yeah.
then this converges.
it converges, yeah.
Let's go.
It converges to that value. See how sometimes it converges and sometimes it doesn't? It's unbounded. Okay.
And FRQ. Okay. I write the whole thing. I put converges to 4 to the 5.
Yes. As a matter of fact, I guarantee, I feel like this is a year. I don't think they asked one of these last year. They average one of these every 2 years. This is, well, I shouldn't say that. I'm going to delete that because I shouldn't be predicting. I have a feeling this year's they're going to ask one of these.
And so is there going to be like a justified reasoning, or is
This is your justification right here. Make sure you write the limit. If you just do the antiderivative and you plug in values immediately, not even a point, because it's an improper integral. So you must identify that it's an improper integral. Okay. So look at this one here. Is this an improper integral? I don't know, Chop. You don't think so? Is it?
Imaginary number, no?
No, we don't deal with imaginary in
Oh,
calculus.
no, you do. Oh, wait, no, it's a cube root. Never mind. Sigma, I mean.
wait, but does it have to be okay? If a point equals 0, does it have to be at one of the two? Because when x is equal to -2 or 5, then the bottom is 0.
Yeah, is -2/5 between here.
Oh, it's something
And
in
here.
between? Then yeah, then it's improper.
It's an improper integral.
I didn't even think of that. That was genius. I didn't know that.
5x equals -2, x equals -2/5. So -2/5 is the value that makes this expression undefined. Is -2/5 between -9 and -8?
Yes. So it doesn't
Yes.
in between. It doesn't have to be necessarily one of the ones.
Correct.
You get to pick which one you want to.
No, we're going to have to break it up into 2 improper. This is why I like to go down the alphabet, but you can always do the Ramirez method. I'm giving her a hard time, but what's up?
I'm like, okay, girl, I just figured out that.
Anyway,
They're all in the domain?
they're all in the domain except for -2/5.
Yeah.
Oh,
It's a vertical asymptote. Oh, 2/3. It's a vertical asymptote. It's undefined.
Saying like there's like a gap where the expression is going.
sorry, Tom. I know the difference between a hole and a vertical.
No, I know. If I had a factor in the top that canceled out, then it would have been a hole.
Yeah.
What's up? Ask. Okay. We're ready? So here we go. I'm going to have to break this up into 2 integrals. So I'm going to go like this. And I'm just going to go down the alphabet. We got lucky. It might be A and B anyways. But here we go. I'm going to write integral. Well, actually, I'm going to write the limit word first. Limit. And I go down the alphabet. As A approaches -2/5. Now, I have to start at -9 because that's my starting part. So if I start at -9, -2 is going to be to the left or to the right?
To the right.
No, to...
Oh, like from.
Yeah,
To get
I'm going from -9 to -2/5. So I have to approach -2/5 from the left. Does that make sense?
Yeah. Oh yeah.
Because I'm starting at -9.
Because you're going from left.
Left to right, yeah. So so as A approaches -2/5 from the left, and I write integral from -9, actually you would write B instead of, but that's fine. From -9 all the way to A, but if you wrote B, that's fine. Delta Math would have written B if you want to write it as B. Of this, 7 over 5x plus 2.
I'm gonna give you that whole.
Yeah, that's fine. Plus limit as B approaches -2/5 from the right, integral, and I'm going to write the letter B. Let me erase this here because I wrote space there. All the way to 8 of 7 over 5x plus 2 to the 2/3 dx. Are we okay?
Oh, fine. I was already done.
Okay, I'll see if I can use two different colors. I'll use the sky blue color for this one here, and I'll use the red one for the one on the left. And I got all this space. That should be enough space. All right, limit as A approaches -2/5 from the left, and I'm going to do antiderivative of that expression. So -2/3 plus 1 is 1/3. So I'm going to have 5x plus 2 to the 1/3, but I have a 5x in there, so it would have been times 5, so it would have been divided by 5. Okay, I'll wait. Oh yeah, the 7 is still there. Yeah.
It's switched, right?
So 7.
Hmm? Is everything correct? Make sure that everything's correct. Did I? Oh wait, did I already divide by 1/3? I have not. Divide by 1/3, so times 3, so 21. Yeah, you guys gotta call me out. I didn't do that on purpose. I didn't divide by 1/3.
What do you want? Oh yeah.
Yeah, 21. Can you do something for me?
Yeah,
Okay.
that's exactly what I was thinking.
So,
I was like, is that gonna move us?
yeah, Drake took calculus. That's why he did it. That's why 21 Savage did that.
Exactly. That's why.
Okay, here we go.
Man, you were his teacher apparently.
Nah, I wasn't his teacher. That guy's like 35.
Wow.
Maybe even 36. I don't know. All right. Here we go.
I was trying to ask.
All right, here we go. Let's focus. Yeah, sorry guys. I it was my fault. I distracted you guys. Oh, I'm kind of old, miss. I mean, I hope I'm not ancient yet, but all right, here we go. I don't see any mistakes. Bracket from -9 to A, and I'm going to change my color, plus sky blue, and then I still have that same thing. Yes, miss. Did I make a mistake?
No, I was just gonna
Ask.
ask. Okay, so for the interval -9 to 8, so if I factored out the 21 bits and then I like put
Yeah.
parentheses for 5 and 6 on there,
That's
can
fine.
I put the interval outside of the
Outside of the limit?
outside of the 5 right?
Yes, you can factor out a 21.5 outside of, oh, I didn't even write the word limit here because this is a different limit. Dang it. It's because I got distracted. I got distracted by my own distraction. It's a different limit, so I have to put the word limit. Ask. We're okay? Okay. So here we go. If I put, oh yeah, it's going to 0. Okay. Limit, I should have enough space in there. As A approaches -2/5 from the left, and I'm going to put the A first. I'm going to factor out the 21 over 5. Big parenthesis, 5A plus 2 to the 1/3 minus -45 plus 2, -43 to the 1/3. I'm not going to bother with that. big parenthesis bracket plus, yeah, that's going to zero out. It looks like this is going to converge. Limit as b approaches negative 2/5. Let's see what it converges to. Bracket 21 over 5, big parenthesis, 5 times 8, 40 plus 2, 42, giant parenthesis, 42 to the 1/3 minus 5b plus 2 to the 1/3, close parenthesis, bracket. Okay. Yeah, to me it looks like it's going to converge. So it looks like, and I'm going to change the color to burnt orange. You guys okay with that? It looks like this one that I'm circling is going to approach 0 because I'm plugging in negative 2/5 into A, right?
Oh, yeah.
Direct substitution. And I'm doing the same thing with this one, and that one's going to approach 0. So let's see what I have. I have 21/5 times 43 to the 1/3 plus, same thing over here, plus 21/5. Oh, this one's 42. Did I mess up with the counting? 42 to the 1/3. I'm going to leave it like that. Let's see what the key says. See if they simplified it. It converges though. And this is some number. I want to see how they left it or how they did it. Oh, they didn't even bother. They didn't even bother. Look at that. They did the same thing we just did. They didn't, actually, ours is even better. What's negative times a negative? No, ours is correct. This is positive. Look, they put a negative in the front. No, it turns positive. Because it's to the power 1/3. Let me look at mine. Yeah, mine's right. It's the same. If it would have been to the power 1, as long as this is an odd, which it is, 1/3, negative times a negative is a positive.
Do we factor out 21?
They didn't. They left it. They left it 21 over 5.
So cool. I just on my own. I kind of did.
Yeah.
Did you get 21 over 5 times 42 to the power 1/3?
Times.
21 over 5 times 42 to the power 1/3.
Yes. It is an AI, so it should count it correct. And there it is. That's about as hard as it gets. What do you guys think?
What are the first problems?
Oh, the first problems are yeah, you'll take care of them real fast.